Thank you, Christy. Great to be back in Singapore, and sadly it's 35 years of experience now. Time's moving on. When you think about future-facing commodities, you might not think about iron ore first thing that comes to mind, but as you'll hear from me in the next 15 minutes, magnetite, as one of the key iron ore minerals, is very much a critical mineral for our future, and in fact one of the most important future-facing commodities. I'll be talking about our project, which is based in South Australia. We're a small company with a monster project. As you heard from Christy, 6 billion tonnes we have in mineral resources. And we are in the middle of a massive and profound transition from steelmaking as they decarbonise and move away from carbon and coal-using technologies to technologies that need to use hydrogen and therefore a very high-grade iron ore. And I'll explain that as we go through this process. But on the right-hand side of this slide, from an investor's perspective, you'll see that the time is now, if you're thinking about investing in this huge space of future-facing commodity of magnetite, now's the right time. We're actually a very unnoticed company at the moment, very small market cap, but we've spent the last 2 years rebuilding the team, including the board and management, to time the project delivery of our project in line with what's happening in the global steel market. For example, Simon Wonke, the second director on the left-hand side here, he was the CEO of ArcelorMittal's global mining business, for example, up until he retired a few years ago, and he's chosen magnetite mines to join the board. Myself, I come from an operations background, 35 years in large international global mining projects, a lot of time in high-pressure acid leach, nickel and cobalt. I was the president of the Ambatavi joint venture in Madagascar for 3 years. That's an $8 billion nickel and cobalt project, very complex. I'm glad to say that magnetite processing is nowhere near as difficult as high-pressure acid leach. So what's happening in steel making? Steel is a massive industry. It's grown incredibly strongly, as you'll be well aware, over the last 50 years. It's in every part of our built-out environment, and it's continuing to escalate. It's just under 2 billion tonnes a year now of new steel is made, and that consumes over 2 billion tonnes of iron ore every year. But it's a very dirty industry from a climate change perspective. 8% of global carbon emissions actually come from steel making. So this actually is having a profound effect on the climate itself, is the actual art of making steel. You can see from the chart on the bottom left how much of a change has to happen in the carbon footprint of steel makers between now and when the mandates for most of the steel making governments have made to decarbonise their industry. It's absolutely a massive job. Wood Mackenzie have forecast that it's going to take $1.3 trillion to transform the global steel industry, with that spend taking place, it's already started, and through to 2050. The largest global steel makers on the right-hand side here have all made mandates and commitments to decarbonise, partially by 2030 and fully by 2050 in most cases, with China and India, the biggest steel makers, needing a little bit more time to do that. So what's going to happen? What's changing here? Across the top of this fairly busy chart, you'll see the dark lines shows how 70% of today's steel is made. We take medium-grade iron ore, we take coking coal, we ship it to countries that have large vertically integrated steel-making facilities, mostly in China. More than 50% of the global steel is made in China, but Japan and Korea, India and Taiwan are very large steel makers as well in our region. And we turn that into steel in big integrated facilities, producing a very high carbon footprint. Some countries who with lots of natural gas have developed an alternative technology using natural gas and direct reduced iron technology. And after 20 years of the blast furnace operators trying to find a way to decarbonise their blast furnaces and not being successful, they are now forced begrudgingly to turn to this alternative technology of direct reduced iron. So direct reduced iron takes place in the solid phase, and it uses natural gas at the moment. It will use hydrogen in the future, and that product then becomes the feedstock along with scrap metal into electric arc furnaces, and when they run on renewable energy, as you'll see across the bottom of the chart, you can actually achieve a green steel product. So there's a green iron and a green steel product. This will split the steel industry in two. It's already starting to happen. Green iron will be made in countries where there is high-grade iron ore and hydrogen, and it will be shipped to other countries where they have a market for the steel and will have electric arc furnaces. So instead of shipping coal and iron ore in the future, we'll see direct reduced iron in the form of hot briquetted iron, HBI, being shipped around the world. These decisions are being made as we speak. The Middle East is set now to emerge as a major player at the starting point of this transition. Wood Mackenzie here have shown how many EAFs are going to have to be built to make the difference in the carbon footprint over the next 50 years. It's quite profound. 2 years ago, China approved 42 new electric arc furnaces. That was more than the previous 6 years running. China on the front foot. They've actually got 10 direct reduced iron, green iron plants already in development. They're very much, as usual, on the front foot. This is already happening. In Australia, where our project is located, Peter Malinauskas, the Premier of South Australia, 3 or 4 weeks ago asked for expressions of interest for what will be Australia's first DRI or green iron plant to be made in Australia. We'll obviously be making a submission into that process. And just last night, the US committed $6 billion to decarbonisation for industry, including 6 green iron projects in the US. So this, as I say, this is actually happening as we speak. Now, what's the kicker? The kicker is that you cannot use medium-grade ores with high amounts of impurities to feed this new technology. You need a very, very high purity grade of iron ore. That can be made from magnetite concentrates at the mine site. And it's not all magnetites are created equal. Some have more impurities than others when they're concentrated. This bubble chart on the left shows all of the major hematite mines in Australia and Brazil, the blue bubbles of Brazil, some of the Australian magnetite projects that are already running. And you'll see on the x-axis the amount of impurities that are in these products. They're not enough for direct reduced iron. The small little box in the top left-hand corner is how pure we have to get the product to meet the current grade for DRI. Our Razorback project, as I'll talk about in a moment, actually has the ability to meet that specification. And we expect the yawning gap in the supply and demand curve on the right-hand side. This is Wood Mackenzie's data, and CRU have almost identical chart showing that this gap expands massively as blast furnaces come offline and EAFs, which are currently on order, are built and are looking for feed. So this is what's happening. So where are we? We're in South Australia. So the regions of the world that have lots of renewable energy, a mandate to make hydrogen, the ability to do it, and high-grade iron ores will be the winners out of this transition. And South Australia certainly ticks all the boxes. South Australia has had a profound escalation in the amount of renewable energy on their grid. They've gone from 1% in the mid-2000s to 73% last year, renewable energy on the entire electricity network in South Australia. That'll be at 100% renewables in the next 2 to 3 years, well before the government's target of 2030. South Australia also has a lot of magnetite, and we've got 6 billion tonnes just in our projects, as you'll see. And of course, the government now has realised this opportunity, and as I mentioned, it's calling for a hydrogen industry to form. It's supporting that, and now a green iron industry to form on the back of it. This is what our project looks like. It's massive. It's outcropping iron ore. These ridges are pure iron ore. They've got magnetite ridges all the way through. This is 12 or 14 kilometres of 110 kilometres of strike length we have in our tenements. This is our Razorback project. There's 4.5 billion tonnes in this project alone, and last year we converted 2 billion tonnes of this resource into ore reserves ready for development. We're halfway through a DFS to bring this big project to life. Where is it located? 240 kilometres to the north-northeast of Adelaide and 160 kilometres east of Port Pirie. You'll see there's a railway line running 50 kilometres to the north, which is, from an iron ore perspective, is a godsend to have rail logistics infrastructure so close to the project. So that's a big tick for this project as well. We have 2 ports to choose from. We've put green dots on 2 ports here. We see those, along with the government of South Australia, as the logical places for these green iron hubs to form, where hydrogen will come together with high-grade iron ore and produce green iron into the future for export to our regional steel makers in particular. Our domestic steel industry is not that big, but our regional steel industry is huge. The project uses conventional standard technology. As I said, high-pressure acid leach, where I've spent half my career, is extremely complex. Concentrating magnetite is extremely easy. You grind it down to a very fine point, you put it across a magnet, you separate the magnetic particles from the non-magnetic particles, and you end up with a very nice concentrate. It'll look like any other mine as you fly across Australia. For those that fly across Australia, open pits, waste dumps, tailings dam, plant, very straightforward technologies. We've chosen a 5 million tonne per annum output as our logical starting point. Stage 1 for our project will be 5 million tonnes. That's not too big to fail because it's too big a mega project and will blow out in cost and time, and not too small to fail because of poor margins. 5 million tonne is the sweet spot, but with such a big resource, if we stayed at 5 million tonnes, we'd be still running after 90 years on the current resources at Razorback. So logically, we would expand to 10 million tonnes after a few years, and we've established our brand and settled the plant down into production. Capital costs for such a big plant, the bottom line on the table on the right shows you just between $1 to $1.3 billion US dollars is required to get stage 1 up and running, and that will double to get stage 2 up and running to over around $2.5 billion US dollars. So it's a big, expensive project, and as you'll see in a moment, we certainly don't anticipate funding this on our own as a junior ASX-listed company. We had Wood Mackenzie do a piece of work to us to place us on the global cost curve of iron ore production on a value in use basis. So this is where we take all iron ore specifications. Low-grade ores have discounts, high-grade ores have premiums over and above or below 62%, which is the current benchmark you see on the news each night. And we bring all that onto one cost curve by subtracting or adding those discounts and premiums, and that way we can compare all world production. This puts our project and our specification into the second quartile for our stage 1 production and into the first quartile for stage 2 production at 10 million tonnes per annum. So that gave us a lot of comfort of the economics of our project based on the premiums that we'll achieve for this product. As I mentioned, we don't want to, we don't intend to finance this project on our own. This is logically a joint venture with motivated off-takers. Very, very well proven model in Australia for large iron ore projects and coal projects for that matter. And I've spent the last 18 months after joining the company talking to a whole range of potential partners for this project, and there's been a long line. We're actually having the luxury of being able to pick and choose who we want to talk to the most, and we're currently in transactional discussions now with several parties in the region, which I can't talk about yet because we haven't made announcements about helping us fund through the rest of our DFS and get us to an FID, and then and then earn the ability to become a joint venture partner for our project. And this momentum in interest in our project has escalated massively just in the last 18 months. From an ESG perspective, I come from a bigger company background, as you've heard, and myself and the board understand that we need to create the platform of the company that we want to be. We've actually branded our ESG platform. We've called it Foresight, and we are set out to role model stakeholder engagement, and aligned ourselves with our customers' downstream steel industry transparent sustainability reporting functions. So that's our ESG platform. Where are we at with the project? Well, we spent the last year or two knocking over a whole range of milestones on the left-hand side. We're now locking down the last pieces of infrastructure. We're partnering at the moment, as you've heard, and we're about to put our mining lease application into the South Australian Government, which will kick off the formals approvals process. So in summary, what's happening here? We've got a massive decarbonisation tailwind. $1.3 trillion of the steel industry has to spend to decarbonise itself. They are already ordering EAFs, and they're looking for high-grade feeds to feed those EAFs into the future. This will take place over the coming 5 to 15 years. Our project's in a A-grade location in South Australia. We have 6 billion tonnes in resources and now 2 billion tonnes in ore reserves. We're halfway through a DFS. We're progressing this to a 5 million tonne per annum project. We've got great support from the South Australian Government. And I was actually in Canberra last week. I had 20 meetings with senators and members of Parliament. And I think we can expect to see some bigger announcements coming out of the Federal Government of Australia on the green iron front in the coming weeks and months. So from an investor's perspective, those sitting in front of me in this audience, this is a golden opportunity and it won't last long. We are a very small capped, less than $30 million company with a project that has a current NPV of $2 to $3 billion, and that won't last long. So with that, I'll finish. Thank you very much.